In this example, we're going to look at Coulomb's law, specifically the charge line segment. So in a previous video, we analyzed the charge line segment and determined the electric field at any point around it. So I give you the expressions for Ex and Ey, the electric field in the x and y directions, and you'll notice they depend on L, the length of the bar, R1 and R2, the distances from the ends of the bar to point P, Q, the total charge on the bar, and Y prime, the distance from the x-axis up to the point P. Now, maybe we can simplify these expressions into something that reveals the underlying symmetries of the system. So, I start off with my diagram, and I look and I label alpha 1 and alpha 2, two angles with respect to the x-axis. Now, cosine of alpha 1 is simply x prime plus L over 2 divided by R1. Sine of alpha 1 is simply y prime divided by R1. Similarly, cosine alpha 2 is x prime minus L over 2 divided by R2, and sine of alpha 2 is y prime divided by R2. So I can plug these expressions into my equations for Ex and Ey. So for Ex, I plug in sine alpha 2 over y prime and sine alpha 1 over y prime, and I get kq divided by ly prime times the difference of sines. For Ey, I can plug in the cosine term, and I get minus kq over ly prime times the difference of cosines. So putting it all together, I get E is equal to kq divided by ly prime times the difference of sines in the x hat direction minus the difference of cosines in the y hat direction. So now, let's put this equation to use. Suppose I have a case where P is equal to 0 L over 2. It's right along the y-axis. And lambda is going to be defined as Q over L. Well, I can substitute in alpha 1 and alpha 2. We know that alpha 2 is 135 degrees. We're measuring with respect to the positive x-axis. Alpha 1 is 45 degrees. And we get square root of 2 k lambda divided by y prime in the y hat direction for the electric field. On the other hand, let's look at another case. This time we're at the point 0 comma y prime, but L is approaching infinity, meaning I have an infinitely long line of charge. Lambda is the charge density of the bar. So once again, E is equal to k lambda over y prime. This time alpha 2 is actually 180 degrees. It's kind of weird to think about, but if you're infinitely far away from the point P, you need to rotate 180 degrees to be aligned with it. And similarly, on the other side, alpha 1 is equal to 0 degrees. If you're infinitely far away, the angle is just going to be 0. So evaluating the sines and cosines, I get 2k lambda divided by y prime in the y hat direction, which is exactly what we get when we use Gauss's law. So, a few final thoughts. We derive a simple expression for the electric field due to a line segment of charge. And in the limit of infinite line length, we recover the same formula that we derived from Gauss's law for an infinite line of charge. So a few things for you to think about. This equation is not valid for R1 equals 0 or R2 equals 0. So why is that? And it's also not valid for y prime equals 0. So why is that?